5 volts are leading right now. Well, shouldn't the person who takes all the photos
Hello my ninja warriors. So yes, we are back with Black Book practice session. Just confirm whether I am perfectly audible and visible to you, and also the moment you enter the session you have to smash the like button. So I can already see you all. Frock King, I am absolutely fine. How are you? I can see Blossom in Chaos. Very good names you have, huh? Hema, hi Hema, how are you? Hi Kevin. Ma'am, fastly we move to problems. Kevin, yes, we are going to do that. Don't worry about it. Hi Ibu, after so long I am seeing you. Hi Rolex. Hi, we have, okay. Hi everyone, okay. So, make sure that you have smashed the like button, okay. Hi Karthik. Hi Jayashri, okay. So, in just case that you are new to the channel and you are new to my session, this is my brief introduction. My name is Namrata and I have over a decade of teaching experience in both online and offline, and these are my credentials you can see. And let me remind you before I dive into questions that do register for MVSAT because it is absolutely free, and on top of that you are going to get a free detailed performance report, your weak areas, your strong areas. Along with that, you are going to get a chance to win the scholarship for existing Vedantu courses, okay? And you can see that amazing cash prizes and free resources and one-on-one counseling also you are going to get. So make sure that you register because it's absolutely free again. Okay, all right. Now, the very first question from the Black Book, from the chapter limits. Okay, all right. Yes. So, one tip, by the way, one ninja tip is that whenever you see limits question, you have to decide the strategy, you have to decide the planning based on the form of the limit. Okay. So, before proceeding, before starting the question, the very first thing that you have to do is, you have to check the form of that limit, okay. So, now who will tell me the form of that limit? So, ma'am, form is nothing but, if you put 0, this is going to be cos of tan 0. Tan 0 is 0, right. So, cos 0 minus cos 0. So, again 0 by 0 form we can clearly spot. Everybody, yes? Everybody aligned with me? Now, 0 by 0 form. Now, one more thing. Cos tan x minus cos x. So, here I am going to use this formula which is cos c minus cos d. 2 sin c plus d by 2 sin d minus c by 2. Okay, sin d minus c by 2. So, cos. So, 2 sin tan x plus x by 2, or you can write x plus tan x by 2 sin d minus c by 2, so x minus tan x by 2, okay, whole upon x power 4, limit x tend to 0. Okay, everybody, yes, getting it? Now, see, I am going to use the standard limits, right? Standard limits you have seen that sine of 0 upon same 0 is nothing but 1. Sine of 0 upon same 0 is 1. So, here 2 sine. Now, inside the sine I can clearly see the moment you put 0, sine 0 is right here. Okay. Because see 0 plus tan 0. So sine 0 is right here. So I need the same 0. So x plus tan x by 2 I have multiplied it. Okay, so that is standard limit. We can get this is actually going to be 1. But you know what? You cannot divide anything randomly. You have to multiply it. So x plus tan x by 2 I am going to multiply it as well. Correct? And you know what again? X minus tan x by 2. So x minus tan x by 2 you have to divide so that this becomes 1 and x minus tan x by 2 is already there. Okay. So now what is pending? Let's see. Let's understand. First of all, ma'am, we can see a 2 over here. 2, then x plus tan x minus tan x, double 2 and x power 4. So your expression will become limit x tend to 0 to x plus tan x by 2 and x minus tan x by 2. Okay, and 1 upon x power 4 is already there. But you know what? See, this 2 and 2 is cancelled and x power 4. I am going to distribute now x power 4. So this is x and this is x cube. Okay. So x I have given it here and x cube here. So now x by x, tell me ma'am 1. Tan x by x, again standard limit, tan 0 by same 0 is 1. Okay. So x by x 1 and tan x by x 1. But here, can you see this is again 1 by 2 and this is x minus tan x upon x cube. Limit x tend to 0. Okay, now please understand that 2 and 2 is again gone and this is again 0 by 0 form. Here you can apply the L'Hopital. If you apply L'Hopital, 1 minus sec square x upon x cube. Sorry, upon 3x square. 3x square. And you know what? If you convert this, this is going to be cos square x. Okay, 1 minus sec square. So this is minus tan square, right? So minus tan square x upon 3x square is clearly again same standard limit. If I apply, minus 1 by 3 is the right answer, which is matching with option B. Have a look, let me know. Yes, 0 by 0 form, good question. What do you think? Good question. Okay, first question done and dusted. Shall I move on to the second question? If you have understood it, give me a big thumbs up. Next question. Okay, question number 2. Alrighty, everybody. Okay, let me open your chat box right here. Blossom in chaos, blossom in chaos, and good question. Siddesh is saying, Ibu is also saying correct. Okay, thank you for confirming. Now this question. So this question again, form check, everybody, form check. So ma'am, form check if you do, the moment you put pi by 3, so sine 0 is 0. And here you put pi by 3, 60 degree, cos 60 degree is half. So again 0 by 0 form. So now what we can do is, we can even apply L'Hopital as well. Because I told you L'Hopital can be applicable. So cos of pi by 3 minus x, and using chain rule it is going to be minus. And this is what? 2 cos x minus 1. So this is minus 2 sin x. Okay. Minus minus cancel, limit x tend to pi by 3. Now you can put pi by 3 clearly. So pi by 3 if you put cos 0, which is 1. Pi by 3, 60 degrees. So 2 times root 3 by 2. So this is going to be cos 0, which is 1 upon root 3, which is matching with option B. Alrighty, everybody. Okay. So this is a clear-cut use of L'Hopital. Okay. Good question, easy question again. Now the next question. Okay, this is interesting. Okay, so x tend to I minus. X tend to I minus. Okay, I minus. Correct. I minus, let us assume I can be anything. So x is actually tending towards, let's say 1 minus or 2 minus. Okay, in that case, we need to learn that what is going to be fractional part of x. Now, fractional part of x is going to be x minus GIF of x. Okay, x minus GIF of x. Yes, I did solve this similar kind in Sigma batch. Oh, Ibu is actually regular to the Sigma batch. Kya baat hai? I to thought ki you are not watching it. Okay, so tell me, if at all x is 1 minus, then what will happen? So, this is going to be what? X 1 minus, right? So, 1 minus is what? 1 minus h, and this is going to be what? 1 minus, okay? So, GIF of a quantity which is slightly less than 1. I think this color is not visible. So, this is fractional part of x is going to be what? 1 minus h minus 1 minus h, correct? Now, 1 minus h, any quantity inside the GIF which is less than 1 is going to give you what? 0, yes or no? And so, fractional part of x is going to be 1 minus h, approximately it is equal to 1. So, fractional part of x is equals to 1. Now, form check. So, the moment you put I minus, for any integer it is going to be the same thing. So, e power 1, okay, form check, form e power 1 minus 1 upon 1 square. So, can you see that the moment you check the form, you are getting the direct answer, okay? Alrighty, so e minus 2, that's why I always tell you, so this is the kind where if you do not check the form and you proceed the question accordingly, then you are going to be gone, okay? So, sometimes, especially when the question is so conceptual, then only you will get such questions, and while actually just checking the form, you will get the answer, okay? So, make sure that you are doing this nicely. Now, the next question, form check, I told you always. So, can anybody tell me what's the form? So, ma'am, the moment you put pi by 2, this is 0 by 0 form. Now, how to handle 0 by 0 form? So, 0 by 0 form can be handled, what you should do is just take this y is equals to limit x tend to pi by 2 cos x power cos x, correct? Now, take log both the sides. Take log both the sides. So, log of y is equals to limit x tend to pi by 2 and log of cos x power cos x. And this power cos x will come in front. So, this is going to give you cos x log of cos x, okay? Limit x tend to pi by 2, okay? Alright, yes. Now, tell me what the form is this. So, ma'am, 0 multiply infinity, hold on, 0 multiply infinity, 0 multiply infinity, okay? Can we do one thing, okay? This cos x can actually be written down as, see, this is log of cos x upon sec x, where x is tending towards pi by 2. Now, tell me, limit x tend to pi by 2. Now, tell me, ma'am, the moment you put pi by 2 over here, log of 0, which is minus infinity, and now, the moment you pi by 2, 0 by 0 form. So, ma'am, magically, 0 by 0 form you have converted back to infinity by infinity form. This is how we solve. How to solve 0 by 0 form? By taking logarithm and eventually converting into either 0 by 0 or infinity by infinity, whichever is easier for you. So, right now, infinity by infinity was easier. Now, differentiate, because again, L'Hopital. So, ma'am, 1 upon cos x. Okay, L'Hopital, apply L'Hopital. So, 1 upon cos x and derivative of cos x is what, ma'am? Minus sin x. Okay, whole upon sec x. Derivative of sec x is what? Sec x tan x. Okay, so this is sin by cos is what? Tan x, and this is sec x tan x. Tan x gone, so this is going to be with a negative sign. So, minus cos x So answer is what? Tell me, the moment you put x is equals to pi by 2 eventually. Ma'am, minus of cos pi by 2, so minus 0, so 0. So tell me, is the answer 0? No, the answer is not 0. What are you looking for? Ma'am, we are looking for y. And what are you getting right now? You are getting the value of log y. So log y is equals to 0. What does that mean? That y should be equals to 1 because log 1 is 0. So y is 1, that means option A is absolutely right. Okay? Getting it? Understanding it? Can we use apply log and differentiation? That's what we did. Okie dokie? Yes? Clear? Moving on to the next problem, which is this. Again, which form? Tell me. Which form? Form check. Form check. 1 raised to power infinity form, how many of you can see? So to solve 1 raised to power infinity form, what you have to do is, you have to write limit x tend to 0 as it is. Okay. But now, e raised to power. How to solve 1 raised to power infinity form? Let me tell you. So, what you have to do is, you have to first of all apply this exponential. So, whatever is going to happen, that is going to happen in the exponential. E power. Now, what will happen in power? Let me tell you. See, first of all, 1 raised to power infinity. Because see again, this is 0 and, no actually, 1 raised to power, no, 1 raised to power infinity is wrong. Oops. Tell me. So, ma'am, it is 1 plus, this is what? 0. So, 1 power, hold on, I think there is some issue over here. I think that there is some misprint. Let's see, I am not sure. This should be 1 upon x. What do you think? Now it is 1 raised to power infinity, right? Now it is 1 raised to power infinity. So now, how to solve 1 raised to power infinity? Limit x tend to 0, e power. Now, this 1 by x, which is the infinite thing, right? The whole expression, this is becoming 1, this is becoming infinite. This thing which is becoming infinite, now you have to bring it down. So 1 by x. Multiply, now you have to subtract 1 from it. So 1 plus a sine bx upon cos x minus 1. So clearly 1 and 1 cancel. So limit x tend to 0, e power. Okay. And this is going to be what? A sine bx upon cos x. And it is going to be, x is also there. Okay. So now understand that we want sine bx, now we want b over here. Okay. So this b is multiplied so that sine bx by b is 1. So eventually this is going to be e power ab. And cos 0 is 1. So, e power AB. Where is e power AB? E power AB, option C. Okay. Option C is absolutely right. Yes. So, question had a mistake. That should be 1 by x. Okay. Done. Shall we move on to the next problem now? Who will tell me the answer of this question? So now again, the moment you put 0 plus, what is the form? So form is going to be C. Now this is GIF of 1 plus and this is 0 plus and 2 upon 0 plus. Okay. Form check we are doing. Form check. So now ma'am, 1 plus, this is 0 plus. Greatest integer function of anything which is lying between 0 and 1 is 0. So this is gone. This is 0. So this is GIF of 1 power infinity, positive infinity. That means exact 1 power infinity is going to be what? 1. Okay. So directly 1. Option B is absolutely right. This is not an indeterminate form. You might think that it is 1 raised to power infinity form. No, this is not 1 raised to power infinity form. Why? Because in 1 raised to power infinity form, that 1 is not exact one. Right now, we are seeing that this over here, because GIF is there. No, GIF is what? GIF of 1 is the exact 1. Exact 1 power infinity, 100 crore, 1000 is what? 1 only. So no need to confuse this with 1 raised to power infinity form. Ma'am, in 28, how minus 1? In 28, how minus 1? How minus 1 means what? This is how you solve it. Kevin, how to solve technique to solve 1 raised to power infinity form? What you have to do is, you have to first of all write E. Then you ask where this E came from also. Why are you asking only minus 1? This also ask na E. So what we do is, we just write E. Now whatever is making infinity na, you write infinity, multiply. Now whatever is making 1, that same one you have to write minus 1. This is the trick, this is the technique. Hold on now. E. So E is right here. Now tell me which thing was making the whole expression infinite. 1 raised to power infinity now. So infinity is this. So 1 by x. See E, then 1 by x. Then what is 1? So this whole expression is 1, right? If you put 0, this whole expression is 1. So this is whole expression which is 1 minus 1. So whole expression minus 1. So that's the formula you are applying, okay? That's the formula you are applying for 1 raised to power infinity. Now this reverse engineering question, okay? I will highly recommend that you use expansion, okay? Use expansion. So now x. First of all, just tell me what is the form of this. So ma'am, form is 0, cube is 0, okay? And the moment you put 0 over here, this is gone. So ma'am, 0 by 0 form, okay? Now if you want to apply L'Hopital, you can do that. But you know what, I don't think so L'Hopital is going to be helpful, because it might make your question more lengthier. So that's why I told you x plus ax cos x. So what is the expansion of cos x? Cos x, I told you already whenever I teach you that cos x is an even function. So all the powers will be even and alternate sign will be there. So 1 minus x square by 2, that's it, plus dot 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 dot. Minus b sin x, odd function, all the odd powers, x minus x cube by 3 factorial. This is 2 factorial. That's it, whole upon x cube, okay? So now understand that in here there is no constant term, but is there any x term? X term. So I am collecting x term. So ma'am, x plus ax. X, so 1 plus a, okay, minus b. X will remain outside, 1 plus a and minus b. Okay, done, done, done. Plus x square. Can anybody see x square, ma'am? Here so I am not getting x square. Here also no x square. Okay, good, good, good. What about x cube? Are you getting any x cube? Yes, ma'am. Minus a by 2. So minus a by 2 and from here plus b by 6. Okay, and this is x cube. Whole upon x cube. Okay, yes. Now, understand. You want limit of this expression to be equal to 1. First of all, limit should exist. Okay. Now, what I am trying to say is this thing over here should become 0. Why? So, if this is not becoming 0, 1 plus a minus b, and this is becoming some constant, let's say constant 2, constant 3, constant minus 1, minus 2, minus 3, minus 1 by 2, whatever. Some constant will exist other than 0. Then constant multiply x upon x cube. That means if xx, if you separate 1 upon x square, 1 upon x square term will be remaining. 1 upon x square where x is 0, 1 upon 0 square. That will make the whole limit towards infinity, and that's what we don't want, because question is saying limit is existing. That means this term has to go. You have to give sacrifice. Go, go, go away. And you know what, the moment you move ahead, x cube will get cancelled out. So minus a by 2 plus b by 6 should be equals to 1. Okay. So this is going to be minus 3a plus b is equals to 6. First equation, and this a minus b plus 1 is equals to 0. Okay. So now if you add a minus b is equals to minus 1 also you can write. So if you add, what will you get? b cancel. Minus 2a is equals to 5. So minus 2a is equals to 5. A is nothing but minus 5 by 2. The moment you put, so 1 minus 5 by 2, so it is going to be minus 3 by 2. So minus 5 by 2 minus 3 by 2, option A is absolutely correct. Yes. Okay. Now the next question on your screen, here you go. The second last question of the day. Okay. Yes. Limit extend to infinity. Form check. Who will tell me the form? Form. Form check. Faranth, it will not happen. It will not happen. I don't think so it will happen. Okay. So now x minus 3 upon x plus 2. So if you see that this is infinity by infinity form, but eventually using ninja technique, you will know that x minus 3 upon x plus 2 limit extend to infinity is what? 1. Temjabu is saying 1 plus m is equals to b, easily भी आता है without expansion. Yes, but you want 2 equations. What will you do with the help of only 1 equation? Okay, they are asking you a and b. That's why expansion will help you if you need the overall thing. But if you need just 1 equation, 1 relation, then you can apply L'Hopital, then you can apply 0 by 0 form as well. Okay. So, but again, if you have to get into expansion, then why would you do any other thing? You have to anyway go to that route. Then why will you make things difficult? Because one way you will get this expression, another way you will get this expression plus more conditions. So obviously you will choose the second route. Okay. Alright, so now this is 1. Okay, how come infinity by infinity? And the ninja technique says that whenever you see infinity by infinity form and the degree of numerator and denominator is same, okay, then your answer will be coefficient of highest power upon coefficient of lowest power. This is a shortcut. Directly what you can do is take x common. So 1 minus 3 by x, take x common from both the sides. Now put x is equals to infinity, you will realize that it is going to get 1 only, right? So this is 1 raised to power, 1 raised to power infinity, right or wrong? 1 raised to power infinity. Okay, so limit x tend to infinity. Now 1 raised to power infinity is what? How to solve it, ma'am? Limit of x tend to infinity e power. Now this infinity is come in front and you have to subtract 1 from this base. That's it. So e power, now understand, x minus 3 minus x minus 2. So minus 5 upon x plus 2. This is x. Limit x tend to infinity. Now again ninja technique, ninja shortcut. Whenever you are stuck in infinite by infinite form, okay, and the degree of numerator and denominator is same, both are linear, right? Then what to do? Just write the highest power of numerator upon highest power of denominator. So e power minus 5 is option C. 3 incorrect option, then we say right. What happened, Vikas Verma? Which option are you saying incorrect? I don't understand. Okay. Now the last question of the day. Last question, fx is given as this and you have to find fx upon x square. First of all, if you check now f of 0, see f of 0 by 0 square, so f of 0 from here 0 0 0, so 0 by 0 form is there, so you can apply L'Hopital. If you apply L'Hopital, what you get is limit x tend to 0 f dash x upon 2x, or you can do one more L'Hopital and you can write f double dash x upon 2. Okay, so f dash x is equals to what? X cos x. Okay, x cos x. So let's differentiate x cos x. I am differentiating the first row. X cos x. So x cos x derivative is minus sin x plus cos x. And here 2x sin x. 2x sin x derivative is cos x plus 2 sin x. X tan x. X is constant, sec square x plus tan x. Okay, correct? And now everything else will be same. But so this is 1x1 and 1 2x 1. Okay, plus or what you can do, see this is going to be a little lengthy, right? F dash x. Now if you put 0, this is going to be 0, so cos 0 1, so 1 1 1, this is 0, so 0 0 0, so this is actually becoming 0. Oops, this thing is becoming 0. Okay, plus now your first row will be same, so again 0 0 0, so f dash f double. Okay, oops, I think it is bad idea to go with that L'Hopital rule. In fact, I think because it will going to be a little lengthier. Okay, so what we can do is we can first find out fx. Let's find out fx. So x cos x, and this is x minus 2x, so minus x plus, sorry, minus 2x sin x, and now this is 0 plus x tan x, right? And it is going to be 2x minus x, so x. So eventually fx, now this is much easier, minus x square cos x plus x square tan x whole upon x square, and this is also x square, limit x tend to 0. Now solve it. So clearly x square cancels out, and eventually if you put 0, minus cos 0 is minus 1 plus 0. So minus 1, option C is absolutely right. Much easier. Okay. Yes. Determinant solve. Yes. Absolutely correct. Okay. So this was the last question, and you know what? Today's session we have done it very soon, like quickly we have done all the mini questions. So I feel that now we have an idea for how to solve what do we say, how to solve 0 by 0 form, infinity by infinity form, 1 raised to power infinity, 0 power 0, and how to tackle determinant problems as well. Okay, so now once I go, in the comment section you can let me know that which topic do you want me to take next, because 10 o'clock we are fixing that we will solve. Okay, so 15 like 30-35 minutes of problem solving daily, 10 questions we'll practice. So next chapter you are going to tell me. Okay, yes.